Alright, so welcome to the video for lesson number 4, operations with polynomials. So essentially this lesson is going over the fact that we can do multiplication, division, mixed with some addition and subtraction. So essentially being able to combine like terms and be able to do some of the things that we did in previous lessons all at the same time. These questions are not more difficult than the others. There's essentially just more algebra to do for each. Alright, so let's just jump right in here to number 1. So for number 1, the first thing I see is that there's a product of -4 to this second parenthesis or second polynomial. So I'm going to take this -4 and I'm going to multiply it by everything in the second parenthesis. So this first polynomial is not going to change. 2x squared minus x cubed minus 9x plus 1. Notice that some of the terms are out of order, so we'll try and fix that as we kind of get further into this problem. -4x cubed when I distribute, -28x, positive 12x squared, negative and a negative make a positive last time I checked, and we have -4 at the end. Then we're looking for some like terms. So I want to try and put this in order, so I want to have everything with the largest exponent first. So -x cubed, -4x cubed becomes -5x cubed. Then we want to combine our x squared terms. How are you? So we have 2x squared and 12x squared, so that's 14x squared. Compare our x terms, -9, -28, it's -37x's, and 1 and -4 is -3. All right, so let's take a look at the second one here. So the second one here has two products, so two multiplications. Remember the other day we said anytime we see something square, just literally write it twice. So I'm going to rewrite this one as x plus 3 times x plus 3 minus x plus 4 times x plus 4. Now, these two being multiplied together, they're the same exact binomial. So we're going to start to see that there's some patterns that arise here. So I'm going to multiply the first one out to you, but then we're going to look for a pattern together here, and we'll try and quickly multiply the second one. So if I multiply the first one, I have x and 3. I'll make my little boxes here, and I have x and 3, so I have x squared. I have 3x, 3x, and 9. So essentially I'm getting x squared plus 6x plus 9. I know I went through that one quickly, but like I said, this is an easy one. So essentially what I see here is I added the number to itself, that made 6. I multiplied the number to itself, so that made 9. So if I want to multiply this second one out quickly, I know it's going to be x squared. 4 plus 4 is 8, so I have 8x, and 4 times 4 is 16, so I have plus 16. Now, this is the quicker way of doing it, and if you can do it with mental math, that's awesome. If you can't, totally fine. It doesn't matter to me either way. So if you needed to make another little box here and go through and multiply that out, that's fine too. What you will see is the further we get or deeper we get into this course, we start to see that there are some things that can help us do things quicker, and quicker is good. All right, so next thing we have to do is distribute this negative. So we have x squared plus 6x plus 9 minus x squared minus 8x minus 16. So the x's cancel completely. The 6 and the -8 become -2x. 9 and -16 becomes -7. There's our answer. Those of you watching this video have a total advantage right now because the third question has a typo in it. Let me just make sure it's right here. So we want to change one of these numbers, otherwise when you divide you're actually going to get a remainder, which we said can't happen. So we're going to change this denominator to x minus 1. All right, so very important that you watch these videos because sometimes that totally happens. All right, us math teachers, we make mistakes too. So let's take a look at our division. So I'm going to use the tabular method. It seems like a lot of you are doing that in class, which is good. If you're a long division person, I apologize, but it's not that bad. All right, this one's actually just going to have 2 columns. So I'm first trying to create x squared. I know that's going to be x. X times x is x squared, making that -x. Together, these two like terms need to add up to -5x. All right. Something changed here. I already fixed the typo here. I just didn't fix it in your packets. So let's take a look here. Let's restart this third question. I apologize. So looking at this third question, if you look at the numerator, the signs are different here and here from what you saw on your sheet. Okay? So there are some differences there. So we want to change those typos. So if we go through and do this long division using this new problem, we have x minus 3, and again we're making x squared first, so that is x, that's negative 3x. These two are like terms, which we want to make negative 5x, so that would have to become negative 2x. We have negative 2 up here and positive 6, so that all works out. Whew, I think we have it the right way now. So this whole first term here becomes just x minus 2. So what I just circled in red all reduces down to x minus 2. So I have x minus 2 plus x squared plus x plus 1. Combine all your like terms, we have x squared plus 2x minus 1. That's our final answer. All right, let's look at the fourth one. Those of you that were really good at factoring in Algebra 1 might even be able to see a pattern that we're going to find here when multiplying this. Just like one of the other examples, I'm going to do the multiplication first for this first one. And then if you look, the setup is similar with a different number. So we'll try and look for a pattern. So I have x squared, 3x, negative, and 3x, and negative 9. You'll notice the like terms here cancel themselves, making it so that this just becomes x squared minus 9. Well, if I use that same kind of structure or idea, I can try and quickly multiply x plus 4x minus 4. So I know the middle terms are going to cancel because they're conjugates of each other. So I'm going to make that x squared minus 16. If you watch my video for lesson number 1, we already kind of talked about this. If you do some distributing and some combining of like terms, we get an answer here of negative 25. Negative. All right, the last problem. Last problem gives us a lot of info here. So it tells us that we have this polygon, right, that we want to find the area for. Now, we know almost everything we need to know for this polygon, right? But we have to first separate it into shapes that we can actually find the area of. So I'm going to draw a line here. Okay? And I'm going to call this rectangle A, and I'm going to call this rectangle B. Even though that B looks like a square, I'm going to assume it's a rectangle for now. Eventually, we'll see it actually is a square. So, or it might even be a rectangle, I don't know. Let's see. A, we have the right amount of information for. I have a length and I have a width. So I can say the area of A is equal to 10x plus 30 times 6x plus 8. We could do some multiplication. That's a 10. So I have 10x 30. I have 6x and 8. I have 60x squared. I have 80x. I have 180x. And I have 240. So this becomes 60x squared plus 260x plus 240. That's the area of A. So I already know this area now. I need to find the area of B. Well, to do that, I know one side, but I need to find one of the other sides. So I need to find either the length or the width, whichever one is missing. So I know this entire piece is this 15x plus 10. But this small piece is 6x plus 8. If I subtract those two expressions, I'll get this remaining piece that I want to know. So if I do 15x minus 6x, well, that's 9x. And if I do 10 minus 8, that's plus 2. So now I know the dimensions of B. So for the area of B, which I'll do over here since I don't have a ton of room left. I have 2x plus 15, and I have 9x plus 2. So the area of B, if I do my distributing this time instead of doing the box method, I get 18x squared plus 4x plus 9 times 15. That I might actually need a calculator for. Let's see. I think it's 135, but let's just check. Hey, look, it is. Pretty good mental math. So I have 135x plus 30. Combined like terms, the area of B is 18x squared plus 139x plus 30. Now our last and final step is to find the total area here. So we'll say the area of the figure is equal to this area plus this area. So if I add those up, I have 78x squared. I take 260 and add 139, and that gives me 399, so 399 x's. And 240 plus 30, well, that gives me 270 in total. Now, this problem uses what we know from geometry and applies it to what we're learning now in Algebra 2. So it's kind of one of those complex questions that isn't, I wouldn't say, a difficult problem, but there's just a lot of steps and a lot of things to